Welcome to another video. Today we'll be showing you how you can make a simple live Wi-Fi weather dashboard running on the Arduino UNO R4 Wi-Fi board with no additional hardware. We'll show you how to build and debug it right inside of Visual Studio with one of our portable solutions. All you need is one UNO R4 Wi-Fi board with no extra sensors or hardware. We'll fetch the live weather data from weatherapi.com with a free account and display it on the built-in LED matrix. Prices for the weatherapi.com system start from as little as $0 per month, with 1 million calls allowed per month. So if we go and sign up and fill in our email address and choose a password, then we'll be able to get access to this so we can download and integrate the data from this API. Once that's done, you'll just have to use the email sent to your email address to verify your account, and then you can log in, and the API key that you'll need to put in your Arduino code will be shown. Now we can go to the portable solution, which we have downloaded from the link in the description and extracted to our PC, and open this in the version of Visual Studio which you are using with Visual Micro. Now we've got the project open. We can see there are a number of INO files, and in the comments at the top it shows exactly what is included in this portable solution, just for clarity. So we have the board package and all of the libraries needed, and you can use either the serial debugger or, as we will in this case, the hardware debugger. All of our API keys and passwords are in the secrets.h file to make things simple and easy. And as you can see, the code is quite brief. It simply connects to the Wi-Fi, and we've got a little delay if we are debugging just to allow it to attach. And then in loop we can see it will fetch the weather at a regular interval, and if it's not fetching the weather, it'll keep scrolling the same results it received last time. We can navigate to our function definitions quickly and easily with the right-click menu, or by simply clicking the shortcut F12 key, or we can peek the definition so we don't lose where we are in our current code file. And just to show the Weather API sketch, this is where the main work is done to connect to the API server and download the data packet with all of the weather information in, and parse this so we can display the elements we want on our LED matrix. This touches on a number of useful features for education, and because there's no additional hardware needed, it's nice and quick to get set up. If we now go and select our board, which is the Arduino UNO R4 Wi-Fi, and ensure the COM port is selected with it connected to your PC, you can just go and build and upload this to try it out. Now, if you wish to debug the code, so you can see what's happening step by step, simply select the debug build configuration and then change the debug option to hardware. Now we can select the CMSysDAP built-in option for this board, which means we need no external debug probe or wiring. There are extra links shown in the description with further help. So we can now go to our code and we can set some breakpoints once the Wi-Fi is connected, for example, and we could go into the fetch weather function and we could add another breakpoint so we can see the data that's received back from the API in detail and inspect that for any other fields we might want to display. We can also add a tracepoint, which will add extra information in the output window when the code executes. For example, we're just going to show the text weather updated and the current temperature returned from the API. But you could modify and expand this to show whatever you need, like other variables such as the condition or the completed weather text. If you do want to stop here instead of it skipping over this and just showing the message, simply uncheck the Continue Code Execution button. So now we can just click Start Debugging on the Debug menu, which will build and upload our code to the board, as well as start the debugging session. Once it launches, we'll land on our first breakpoint that we set in Setup, and we can inspect variables and step line by line through the code from there. So now we can see it's landed on our breakpoint, and we can go and look at the autos window, which will show any variables automatically put in there, as well as the locals window, or if you wish to have a specific watch, the watch window. If we continue, it then moves on to our breakpoint where the payload has been received, and we can inspect the buffer, so we can actually look at the data returned from the API in full. As you can see, after the HTTP header information, there are a lot of other bits of weather information returned from the API which aren't in use in this sketch at the moment. And we can step line by line through the code with the step over button. And of course the step into and step out buttons work as normal. If we continue to our final breakpoint, we can see our message that was put in, showing the weather updated text and the temperature. If you see some variables are optimized out, you can change the optimization on the vMicro debugger menu to reduce the likelihood of this happening. And we can also add any other variables in scope into the watch window, so we can review the data as we hit various points in the code. Very useful for either solving problems or demonstrating how things work in an education setting. Don't forget to like and subscribe if you enjoyed this video, and don't forget to let us know in the comments any feedback you have or any future suggestions for videos that you'd like to see.